I know that you have specialized in some programming language or two and would prefer to use those when conducting your hand calculations. But in industry, from what I've seen, often Excel is still utilized as the primary hand calculation software. I discussed some common mistakes and best practices when utilizing Excel for hand calculations, but they may be adjusted to apply to your quick calculator of choice. The first mistake that might occur is your formula construction. Having hard-coded values in formulas, like constants embedded in calculations instead of in separate cells, including magic numbers not stating any source or documenting the origin, use, or copy-pasting values instead of linking the data to the original source. You may have some excessively complex formulas where you have multi-operation formulas, which are difficult to debug, or nested if statements beyond 3 to 4 levels, or array formulas without clear documentation. And there may be errors in cell referencing. There may be a need for an absolute reference and you use relative references. There may be some broken links when sheets get restructured or circular references that result in calculation errors. To save yourself from these mistakes, make use of formula construction techniques. Use named ranges and variables, having descriptive names for input cells, named formulas for complex calculations, and dynamically named ranges in data tables. You should also do a modular calculation breakdown with complex formulas broken into logical steps. Also, having helper columns showing intermediate results aids the user to debug or understand the calculation better. Additionally, always have structured references in your table. Then, on to handling units. Use consistent units throughout your CalcSheet with clear conversions worked in. Always have the units explicitly noted next to the appropriate values and keep the conversion factors isolated in a dedicated area. This reduces user-imposed errors. The second mistake often seen is in spreadsheet organization. You could have poor input and output separation, like having them mixed throughout the sheet, with no clear visual distinction between inputs and outputs, and having results scattered throughout the workbook. You might have inadequate documentation, where you might not state units of measurement. You might not have explanation of your calculation methods, and you have variable names and abbreviations that are undefined. You might also have some version control problems where there are multiple copies around with inconsistent updates, or no tracking between versions, and an inability to recover previous calculation states. The practice that you would implement to circumvent mistakes with spreadsheet organization would be to organize the structure of the Excel formula sheet. Use a consistent layout framework where rules are applied to all your Excel calc sheets. For instance, having dedicated sheets for inputs, calculations, and results. You could use a color coding system, visually directing the user to blue inputs, green outputs, or something along those lines. It's really beneficial if you stick to a standard template structure for all your engineering calculations. You should make use of structured data flow architecture, a top to bottom and left to right calculation flow, with clear separation of raw data, processed data, and results. With this directed flow, it should reduce the amount of unnecessary circular references where these are not applicable. Finally, you should include documentation integration where you state your references and standards explicitly. You have a revision log and your assumptions are clearly stated and highlighted. The third mistake we might encounter is about validation and error checking. You might not trap errors sufficiently and have no input range validation. Maybe there are some missing checks for physically impossible values, or maybe your calc sheet breaks with certain input combinations. This might be from inadequate testing, where you don't verify against known results, or you lack a sensitivity analysis for inputs, and you completely omit boundary condition testing. Then, there might happen some hidden calculation errors, like incorrect order of operations in formulas, remembering BODMAS, or unit conversion mistakes, or rounding errors introduced in intermediate steps. We don't like making mistakes, and the best way not to make mistakes is to include validation and error proofing. It's more work, but you'll feel like less of an idiot at the end of a high-pressure week with low mental capacity when your error proofing saves you. You should implement data validation where you have input range restrictions like minimum and maximum values. You have drop-down lists for categorical inputs and custom validation formulas for the more intricate parts of your calc sheet. These should include error messages. Then, you should also include error checking protocols. You might write them out in a separate sheet if it's a widely used calc sheet, but having conditional formatting is a great way to visually identify problematic values. Then, having error trapping functions, such as if ISERROR constructs. There might be alternative methods that you could implement for your specific case. And finally, you should use an auditing and testing framework on your CalcSheets, where you benchmark, test against known solutions, run sensitivity analyses on critical parameters, and do automated tests with VBA or Power Query.